So, the car starts from rest when there's a distance s from the starting point, its speed is v, and its acceleration equals 25v plus v cubed. Find correct the 3 decimal places its speed when s equals 0.02. Okay, so what I suggest here is that acceleration equals to v dt, but it's not in terms of time, so you need to make an adjustment using the chain rule. So you use the v ds by ds dt using the chain rule. ds dt is v, so it's v times the v ds. V times the v ds ends up to be 25v plus v cubed. You then move it on to one side, and we're going to get v over 25v plus v cubed. We can factorise that, and we can turn that into 1 over v squared plus 25. And we can leave the other side as just ds. Okay? Now, you can do this 2 ways. You got to understand that there is no distance when there's no velocity. Oh, sorry, just give me 1 second. That actually says it starts in rest. So no velocity when no distance is travelled. So that's 0 and 0, only because it starts from rest. Okay, I can call that s, or alternatively I could sub in the point 0. What's a 0.02, is it? The 0.02 could go in there, but I won't. I'll just leave it till the end because I want the generic equation anyway. So that's v. Now, and what is its velocity? What is its speed when s is 0.02? Okay, so that's tan inverse. That is the integral of 1 over 5 tan inverse v over 5. Because you change 25 into 5 squared, you look up the tan inverse rule. A is 5, so it's 1 over 5 tan inverse v over 5 from v to 0. And then it's equal to s from s to 0. That's s is equal to 1 over 5 tan inverse v over 5. Replace s with 0.02. Because that's what s is. Multiply it by 5, because we're going to get rid of that fifth on the other side. So we're going to get 0.1 equals tan inverse v over 5. Using radians, v over 5 equals tan inverse 0.1, and v therefore equals 5 times tan inverse 0.1. And what you get, v equals 0.498.
Sure.
Yeah?
I did everything like that up to the very last bit.
Yeah.
How did you get the last bit?
Actually, sorry, I think, is it 4.98?
No, I didn't get anywhere near that.
Okay, just give me a second. So, I brought the 5. Are you with me till this point here?
When you bring the tan inverse over, why does it not become tan?
Oh, it does, sorry, it does. Sorry, my fault on that front.
But then 5 tan of 0.1 is 0.008726. But the answer is not.
Just give me a second. 1 over 4 tan inverse. Yes.
5
tan.
0.1.
Yeah, just maybe your radians weren't on.
Radians, you have to do that.
Yes.
Why?
The maths is calculated on radians. Integration is calculated on radians, never degrees.
It should be way bigger then.
Yeah, just give me a second.
0.1 radian.
Just shift setup, shift setup, shift setup. Radians. Sorry, 1 second. So it's 5 tan 0.1. Oh, a minute. 5 tan 0.1.
The integration is always in radians.
Yeah, 5016. Is that the answer in the solutions?
Yeah.
5016. Yeah?
Okay, so you just have to convert to radians then, or to degrees if you want.
No, leave your calculator in radians.
How do you do that, sir?
I'll show you now.
Fine.
I suppose you don't know that. 5.510.116. Okay, if you look at, see the little R on top?
Yeah.
So you press Shift, Setup, and you see degrees is 3, radians 4, grad is 5. So you press 4. Alright?
That's fine, man.
Alright. Part B. Where is part B?
I did it last year.
Yeah, I did it last year. A particle of mass 5 kilograms moves along the line, the x-axis on a smooth horizontal plane under the force of newtons of 40 minus 3 root x, where I is the unit vector along the x-axis, and x is distance the particle from a fixed point O of the axis. Particle starts from rest. Its speed when x equals 80. So it's going to be a times v times the v dx. Now force, which is 5a, equals 40. Now just it's not proportional, it equals that, so it's 40 minus 3 root x. Divide that by 5 and we get a equals 8 minus 3 over 5 root x. We then, once again, there's no time on this question, in the first part anyway. Second part might be different. Find when it next comes, it's not the time, so there's no time in this question, so we can be completely independent of time here. So we're going for v times the v dx, ends up to be 8 minus 3 over 5 to the power of a half. Integrate both sides, and we get v times the v equals 8 minus 3 over 5 x to the power of a half dx. And I'm going from, is it x to 0, guys? It starts at rest, so phi to 0 as well. Phi squared over 2 from phi to 0. 8x minus, that's going to be 3 over 2. Which means I have to multiply 2 over 3 by 3 over 5, which will give me 2 over 5. And then I have the joy of putting in x and 0. Okay. And what you say, I have to put in x equals 100, is it? So replace x with 100. So it's going to be phi squared over 2 equals ax minus 2 over 5 x to the power of 3 over 2. But we know that x equals 100, so we can put that in. We get phi squared over 2 equals 800 minus 2 over 5 by 100 to the power of 3 over 2. Phi squared over 2 is actually going to end up to be 400. Phi squared equals 800. Phi equals 20 root 2. And we get 20 root 2? Or a version of that. $28.28.
You dropped me a mark here along the way, I have no idea why.
Okay, give me a look at it in a second. Let's mark it off and I'll have a look at it after C. You okay with that?
Yeah, I got that.
Okay, good man. Now, a car freewheeling on a straight road experiences a retardation which is proportional to the square of its speed. Acceleration is equal to minus k v squared, where k is some constant of proportionality. Actually, I skipped part 2, didn't I? When does the next come to simultaneous rest? Just give me 1 second. When does the next come to simultaneous rest? It comes to rest when phi equals 0. Sorry, I forgot part 2. And we know that the formula is phi squared over 2. Phi squared over 2 equals 8x minus 2 over 5 x to the power 3 over 2. Well, we know phi squared over 2 has to be equal to 0 then. And then we get 8x minus 2 over 5 x to the power 3 over 2. Factorise out x, and you get x into 8 minus 2 over 5 x to the power of a half. You either get x equals 0, or using this part here, we get 2 over 5 root x equals 8, root x equals 20, x equals 400. Sorry about that. Tom, last part of differential equations. A car freewheeling on a straight road experiences a retardation which is proportional to the square of its speed, minus kv squared. Its speed is reduced from 30 to 10 meters per second in a distance of 120 meters. Calculate the time taken to travel this. So, A can be written as phi times the v dx or ds, whichever letter you want to choose. Okay? So we have when x is 0, when we start our experiment, we know that the velocity is 30. However, when x is 120, our velocity is 10. The whole point of the question is to find the time. So find the distance. Distance is 120. Okay. I'm going to find k using all this information. K is what I'm going to get out of this, because I have all the limits. Like I have once I work on this, I have all the limits I need. So the only thing I'm going to get out of this is the k value. So equals minus kv squared. It's going to be phi over phi squared equals minus k dx. Phi over v squared is 1 over v. I'm integrating a log. 1 over v is going to be a log when I'm done. I'll move that 1 over v to v, and then k times dx. 0 to 120 and 30 to 10. Now, what we can get here, there's a little bit of jigging to be done here, but we can get lnv from 10 to 30, which ends up to be ln 10 minus ln 30, using the rule of what's that word? Using the negative log rule, yeah. That's ln a third. Would you agree with that? Ln a third, which in turn is ln 3 to the minus 1, which in turn is minus ln 3. If you kept it as ln a third, you'll still get it right. It's just a more awkward number to deal with.
So if you leave it as ln 10 minus ln 30, you'd just get a figure, couldn't you?
Yeah.
Decimal way.
Yeah.
You would, wouldn't
You could, but say this is better on accuracy, like. But yeah. Now, you want to keep, if you can avoid rounding off, do it.
Just save it as a book on your calculator.
What?
Save it as A on the calculator or something.
Yeah. 120 and 0 minus 120 k, yeah? So minus 120k equals ln 3, k equals ln 3 all over 120. Now, what we're dealing with next is time, okay? And to use time, what we're going to do is time. So t will equal 0 and t equals t. That's what we're trying to find out. What is that other t value that we don't know? So remember that v equals velocity equals ds dt. Okay? And if we go back to our workings earlier, so we're just going all the way back up the top, and we're looking for the time taken for this to happen. ds dt. Does that link it in? No. We're not going through it that way. What we're going to do is go back to the very top. Acceleration equals kb squared. And this time we're going to use the variable t. So the v dt equals minus k v squared. Bring it over and we're going to get 1 over v squared dv equals minus k dt. T is 0. I'm going to leave k the way it is for a while. Just not going to change it to the very end. And v is here. Now v starts off at 30, ends at 10. Integrate. I'm basically integrating v to the power minus 2, which turns into minus 1 over v, or minus 1 v to the minus 1. And that is from 10 to 30. The other side is minus k times the integral of t from t to 0, basically minus kt. This one here is minus a tenth plus a 30th. Now a 30th plus a tenth is going to give me minus a 15th. It's minus kt. Reverse the signs at 15th. 1 over 15k equals t. We know that k equals 1 over 15 times 120. Is it ln 3 over 120? ln 3 over 120. ln 3 all over 120 equals t. The t value is 7.3 seconds. And that's us.